Saxon Algebra 1/2, lesson 30. You guys, we're going to talk again about one of the most annoying steps in our work here, and that is adding and subtracting fractions. Here's the thing that we know about adding and subtracting fractions. Here's a really super easy one. The denominators have to match before we can add them. And so we have to adjust denominators so that we have to adjust the fractions so that the denominators match before we add or subtract. So I'm going to write it here. Denominators must match. Now, this example that I gave you is pretty easy because we can just go, oh, 1/2 is the same as 2/4, and then we can add them. Okay, that was a really easy one. But we're gonna practice, how do you do this when they're not so easy? And we only have 2 examples, but they are gonna be doozies. Now, the first thing I'm gonna tell you is don't write it like this. This is called horizontal presentation because it goes this way. We always wanna use vertical presentation. I'll tell you when we can stop doing it this way, but we're always going to write them this way. And here comes our problem. 5/11 minus 1/5. All right? The reason we want to do it this way is because we want a lot of room to make our adjustments going this way. And if we just try to squeeze it all in, it gets messy and confusing and ew. We don't want to be messy or confusing. So please do it this way until I tell you, okay, we're not going to do it that way anymore. All right? And that day will come soon. So the first step is to find the least common multiple. And again, that means the number that both of these numbers will go into. Now, sometimes the smaller number will fit into the bigger number. Like here, right, we had 1/2 and 1/4. Sometimes you can just adjust one to make it fit into the other, but 5 does not multiply times anything to get 11. So that means that the least common multiple of this, because these are both prime numbers, we know there's no easier way to do it. It's just going to be 55. It's going to be 5 times 11. All right? When we get into factors that have trickier LCMs, we're going to talk about strategies for that. If the LCMs are prime number, or if the denominators are prime, we just multiply them together. And since 11 and 5 are both prime, we knew, okay, 5 times 11, 55. Okay, step 2, adjust the denominators to the LCM. All right, so we have to turn these fractions both into 55. So we know we're going to use the numerator, denominator, same quantity rule. That's what this box tells us, is that we're going to multiply top and bottom by the same number. The number that we put in this box is going to be whatever it takes to make this denominator turn into that denominator. That denominator is our LCM. What do we multiply? 5. 5 times 11 gives us 55. Cool, check. Top has to be the same. And so now we have 25 up top. Okay, so there's our new fraction on the top. And now we're ready to adjust this one. Same thing, we're going to use the numerator, denominator, same quantity rule. Multiply it top and bottom by the same. We have to end up with 55 in the denominator because that's our LCM. 5 times what gives us that? 11. If we multiply by 11 on the bottom, better be 11 on top, better be Gryffindor. 11 times 1, 11. Whew. That was fun, right? So that now and so the third step, which is really part of the second step, is we write new numerators. right? First we fix the bottom and then we fix the top. So 2 and 3 are steps that go hand in hand, and Hannah Cranny is going to be all over you to make sure that you do. If you're going to do 3, you've got to do 2. I don't know if Alexis has ever heard the story of Hannah Cranny. I'll tell you soon, Alexis. But basically, she's a former student of mine who was very serious about making sure that things were always fair. And if you're going to multiply the bottom by a number, you better multiply the top by the same number, or it's not fair. So Hannah Cranny keeps us following that numerator, denominator, same quantity rule. And in that way, she's very helpful. Okay, now we've got our new numerators. So our final step is to simply add or subtract as we're told. And so now we can go 25 minus 11 is 14 over 55. Remember, when we add or subtract, we combine the numerators as we're told, but the denominator stays the same. And then the 5th step is reduce if possible. Reduce if possible. 14 over 55 will not reduce. Here's how I know. Here's how I know, you guys. I think about prime numbers and I go, okay, if this is going to reduce, that means the same factor has to be in the top and the bottom. 14, I know the prime factors of 14 are 2 times 7. 55, I know the prime factors are 5 times 11. They don't have anything in common. So that means we won't be able to make this any smaller. So that's our final answer. Yay! That's a super shortcut, you guys. Twice in this problem we used prime numbers. We used it to calculate the LCM, and we used it to see if we could reduce. Prime numbers are fabulous. They help us so much with our work. Okay, one more problem. Example 30.2. And this problem is a juicy little meatball. Let me show you. Because it's 3 fractions. What? Right? This one was 2, this one is 3. Now notice John doesn't do it like I do it. He just goes across. I like that vertical presentation. Do it my way, you guys. It's so much easier. All right? So this one, we're going to have to go 1 over 4 plus 5 over 9 plus 2 over 3. We're adding all of those together. All right, step 1, LCM. All right, so now we have to look at our numbers and see what we can figure out. I see right away that 3 goes into 9. So if I find the least common multiple of these two, I know that 3 will fit into it as well, because whatever 9 goes into, 3 is going to go into. So now I look at prime factors again. I'm just going to write down 4. If I break 4 down into a prime factor tree, it's 2 times 2. And if I break 9 down, it's 3 times 3. Okay, so they don't have anything in common that's going to help me. So it's going to have to be 4 times 9. It's going to have to be 36. Does that make sense? There's nothing smaller that both of those numbers will go into, and I proved it by just looking at the prime factors. They don't have anything in common, so I can't make a smaller number. I just have to multiply the primes together. All right, but that's fine. What that means is that we're going to have to multiply each one of these fractions, numerator, denominator, same quantity rule, and end up with a fraction that has a new denominator of 36. And yes, I want you to draw this out just the way I'm doing it, and I'll tell you why. Because if you know how to draw the picture, it will remind you how to do the problem, and you won't forget any of the steps. So please do it this way. I promise it won't be forever. All right, 4 times something equals 36. I wish you were here to solve this for me, but I will tell you. 4 times 9 equals 36. Check, that works. 9 on the bottom, 9 on the top. 1 times 9 is 9. Beautiful. 9 times something equals 36. Well, this is just the opposite of that, so I know it's 4. This has to be 4. 5 times 4 is 20. Is this feeling easy? I hope it's feeling kind of easy. 3 times something equals 36. Well, that's where you need to know your 12 times. And 12 times 2 is 24. All right, now we've got all those cute little matching denominators with their adjusted numerators. We're ready to add 9 plus 20 plus 24. Well, that's 29 plus 24. I'm going to write it down, right? I put those two together because that's easy. And then I add the third one. 9 and 4 is 13. So our answer is 53/36. And once again, I ask myself, can I reduce this? And I go, oh, there's lots of numbers that'll go into 36, right? There's a bunch of them. 9 and 4 and 12 and 3, 6 times 6, but 53 is prime. So he's not going to break down, and this is stuck. John goes ahead and writes it as a mixed number. I don't want you to do that. I want you to leave it just as this. That's the right answer, and I just want to show you. John shows the answer here. I'll move it up a little. John shows the answer here. So here's 53/36. Yay, that's what we want. Then he writes it as a mixed number. I don't want you to take that extra step. Just leave it right there. That's the perfect answer for you. All right? So here are the practice problems. There are 2-parters and there are 3-parters. Just take care to notice what's going on with the plus and the minuses because he's mixing them up within the problem, isn't he? So that's fine. It will only be in your very last step that will matter. Because as you're finding your LCM and you're adjusting all your numerators, it doesn't matter if you're adding or subtracting. That only comes at the end. All right, lesson 30. That joyful little lesson is done. Yay. Good job, you guys. I will talk to you on Wednesday for 31 and 32, and then I will see you later in the week for your review problems. For your video chat with me. You guys are doing a fantastic job on checking in with me on the Friday, Thursday or Friday, it doesn't matter which day it is. But you guys have been doing a really great job. Welcome Joel to the video chat party. He's got his game on. Jojo and Alexis, you guys have been rocking it since the beginning, but Joel's now got the rhythm going. And so you guys are doing great. Absolutely fabulous. So thank you so much for being amazing. Please remember to get those parent sheets signed and please remember to bring them. I know that's a pain because I know that Joel and Jojo, you're at school, so you have to drag your math stuff in to show me. I know, I'm sorry. I know it's not convenient, but that's life in the fast lane. So you're doing it. Keep it up. Thank you. Goodbye.